Okay, here is problem 2 on page 613. This one's a big step up from problem 1. It's way more complicated. And I am going to be referring to the formulas in the formula packet on this one. So here we go. The maximum load a lift can carry, that means an elevator, a lift is an elevator, is 375 kilograms. The weights of adult males and females are distributed normally with means of 85 kilograms and 60 kilograms and standard deviations of 10 kilograms and 7 kilograms respectively. So I'm going to go ahead and write that down. I'm going to have males and I'm going to have females. So I'm going to have males that are normally distributed with a mean of 85 kilograms and a standard deviation of 10. So when we write down the parameters for a normal distribution, it's the mean and the variance. And the variance is standard deviation squared. So that's why I put the 2 on there. And then for females, again, it's normally distributed with a mean of 60 and a standard deviation of 7. So 7 squared. All right. So then it says, find the probability that a load of 3 women and 2 men would be too heavy for the lift to function. Okay, so I've got 3 women and 2 men. So I want to find the probability that 3 I missed it already. 3 women, I'm using F for women, females, plus 2 males is going to be too big for the lift to function. So the lift can function at up to 375. So I want to know what's the chance this is going to be greater than 375. Okay, so here is my problem that I need to answer. So now I need to figure out how I'm going to get this into my calculator. So looking at my formulas here, my expected value that's the same as my mean. Okay, my mean is I can take the multiplier, okay, my A value, and multiply it with the original mean, and then add that to the other multiplier plus the other mean. Okay, so I'm going to be able to get my new mean that I'm going to be using for this problem by adding these two together, multiplying and adding them together. So I am going to have 3 times 60. So this is going to give me my mean. This guy right here, this is my mean. 3 times 60 plus 2 times 85. Okay, so if I multiply that out, which I already did, I get 350. So there's going to be my new average, my new mu. And then I need to find my new standard deviation. Okay, my formula tells me about with variance, I can take the multiplier times the variance plus the multiplier times the variance. But notice how it simplifies it out down here. It's the multiplier squared times the variance plus the multiplier squared times the variance. So that's what I'm going to do. I'm going to do this part right here. So my multiplier is 3. Okay, so for my variance of x, of my new x, what should we call that? X sub n, variance sub n, is going to be equal to 3 squared, because remember it says that I have to take the multiplier squared. 3 squared times the original variance, which was 10 squared, plus, I just did that backwards. 3 goes with the females. Oops. Glad I caught that before I got too far. That was for the females. And then plus 2 squared times the males' variance. Okay, so if I do that, 3 squared is 9. 9 times 49. Did I multiply this out anywhere? No, I'm going to have to do that right now. So 9 times 49. Well, actually, let's just put this whole thing into my calculator, right? 9 times 49 plus 4 times 100. That gets me 841. But that would be my variance. So now I'm going to have to get, in order to put it into my calculator, I'm actually going to need the standard deviation. So that would be my variance. So my standard deviation is going to be equal to the square root of that. So let's take the square root of that, and I get 29. Okay, so when I put this into my calculator, it's going to be this new thingamajigger here with my 3 females and my 2 males. It's going to be normally distributed with an average, with a mean of, what did I say, 350, there it is, and 29 squared is the variance, but I need the standard deviation of 29. All right, so now I need to figure out, okay, I want the probability to be greater than 375. So I want to know, okay, this is now like my x. I want to know what's the probability. So x now is normally distributed with a mean of 350 and a variance of 29 squared. So now for this x, I want to find out what's the probability that this value that's normally distributed with this variance is going to be greater than 375. Okay, and I think this one, I don't need to do the 1 minus. I think for normal distributions, I'm going to be able to put this in directly. So I'm going to go to my distributions, and it's going to be cumulative because anything greater than that. So my lower limit is going to be 375. I want to be above the 375. So this is going to be giant number. I put in 10 to the power of 99. That's a huge number. My mean is 350, and my standard deviation is 29. And hit enter a couple of times, and I get, what's the chance of this happening? The chance of this happening is 0.194. That is my answer. The back of the book takes it to another decimal place, I think, but we always go with 3 significant figures. Okay, so this one was a lot more complicated. So notice what I did is I was using the formulas from the formula packet to help use my original averages, used my linear transformation, okay, I multiply them. When I have a multiplier, and remember the multiplier affects not only the mean, but it also affects the standard deviation. And then I used my little formulas here to help guide me. Okay, so that is the answer to number 2. The chance that they are going to bust the elevator, they have a 19.4% chance of busting the elevator if I have 3 women and 2 men on it. Too many people.